So in this video, we're going to use Trig to answer a few kind of real-life word problems. So sine, cosine, and tangent are going to allow us to solve some of this stuff. Keep in mind as you're working on this, so katoa. So sine is opposite over adjacent, cosine is adjacent over hypotenuse. Sorry, opposite over hypotenuse for sine. And tangent is opposite over adjacent. So we may be using those. On this problem here, it says you're measuring the height of a building. Obviously, there are a few ways to do that. We could try to use a tape measure or something to literally measure it. We could do what we did with the similar triangles, and we could measure the building's shadow, and we could measure like us and our shadow and set up similar triangles and do that whole thing. But setting up all that shadow stuff is not always the easiest thing to do. So another thing you could do is use Trig. So it says you measure the angle of elevation from a point on the ground. So say you're standing like right here. So from a point on the ground to the top of the building, you measure that to be 48 degrees. Estimate the height of the building. This forms a right triangle, and it says you're standing 100 feet away. So this distance here is 100 feet, and I want to know this distance, the height of the building. I'll call it x just to represent the height. I can use Trig to solve this. That's the opposite side. This is the adjacent side. The one that has to do with opposite and adjacent is tangent. So I know that the tangent of 48 degrees equals the opposite side, x, over the adjacent side, 100. Then to solve for x, just multiply by 100, multiply by 100, and so that's it. Put this in your calculator. Don't forget to be in degree mode. So I'm going to type 100 times tangent of 48 degrees is 111.06. I'm just going to round to 06. That would still be in feet. So that's the height of the building, and that makes sense. 111 approximately feet. There we go. A couple things I want to point out. First of all, it says the angle of elevation. That means as you start horizontally and then elevate, it's going to be 48 degrees. We'll talk more about that in a second. Also, how did we know that was 48 degrees? It says you measure it. How do you do that? There are a few different ways to measure angles. You may be familiar with some of these. I wanted to show you some that are used in real life. This is called a transit level. It's used in like surveying, construction, that kind of thing. This one's called an inclinometer or a clinometer sometimes. You may have used this in like an FFA class. Or the club. It allows you to also measure angles. You just kind of look through here. A lot of people in forestry, park rangers might use this to like see the angle up to a tree or something. You may see guys out on the road using this kind of thing when they're surveying for a construction site. There are other ways, like protractors. Also, you may have seen this tool. This is a T-square that just helps measure like right angles for construction stuff. So I just wanted to show you some of those tools that are out there in the world. Okay, so back to this. There are two types of angles you may hear about with this stuff. One is an angle of elevation, meaning you start horizontal and go up. The other is an angle of depression, meaning once again you start horizontal, but then you depress, you go downwards rather than going up. An angle of depression could have like come down this way too, like start horizontal and go down. The angle of elevation and depression should be the same because these are basically parallel lines making these alternate interior angles. So that angle of depression there and this angle of elevation here should be congruent. Here's another example. If this is your eyesight, your angle of elevation would be like up to some object, where your angle of depression would be down. Or here's another example. If you are like here at the top of a cliff, the angle of depression, again, this right here is not the angle of depression. It's got to start horizontal and go down. Or for elevation, you start horizontal and go up. Again, they should be the same. If this is 34, then this is 34 degrees. Here's one final example. Again, elevation starts horizontal and goes up. Depression starts horizontal and goes down. All right, so here's one more example that we'll take a look at. Have you guys ridden on the incline? I actually have not done this in Chattanooga, St. Elmo. So near the top of the incline railway on Lookout Mountain, there is a 72.7% grade. This stands for gradient. It's like how steep is the slope. This is just according to their website. They say it's a 72.7% grade, making it one of the steepest passenger railways in the world. If you traveled 100 feet along the track at that grade, how much elevation will you gain? So obviously the whole train is not, like the whole track is not that steep, it's just the very top part. So that's why I said if you were going 100 feet at that grade. So, couple things. First of all, percent grade is not the same as degrees. There's a conversion factor that you can look up online. I actually had to go look it up, but it's typically about half. So for example, 72.7, cut that in half, it's about 36 degrees. So degrees and percent grade, you know, like when you're going on a steep road, there's usually like a road sign that says, like, trucks, be careful, this is like an 8% grade. That's actually only like 4 degrees. So it's usually about half. Anyway, so if this is a 36-degree angle, let's go ahead and draw this out as a triangle because that's what it is. Here's the track. I'm going to make that my train track. Here's the incline going up the track. It's steep, but not as steep as you might think. Like this feels like it's almost a 90-degree angle, and it's not. It's actually not even 45. It's only 36%, which is still very steep for a train, but not as crazy as you might think. This forms a right triangle. It tells me you're traveling 100 feet along the track. That's not 100 feet horizontal, it's not 100 feet vertical, it's 100 feet along the track. So 100 feet right here. And it wants to know how much elevation will you gain. That would be the height of the triangle, basically. It would be this right here. Elevation would be just like from here to here, how much have you gone up? Okay, once again, we can use trig to solve this problem. That's the opposite side, and this is the hypotenuse. The one that has to do with opposite and the hypotenuse is so. Sine. So the sine of 36 degrees equals x over 100, opposite over hypotenuse. And then to solve for x, just multiply by 100. And type that into your calculator. And we get 100 sine 36. Again, make sure it's in degree mode. And that is 58 about 0.8. So about 59 feet is how much elevation you've gained as you go along the track, which is quite a bit of elevation in just 100 feet. I do want to mention, just a side note, apparently the steepest grade in the US is Canton Avenue in Pittsburgh, Pennsylvania, which is 37% gradient. I think that's a road, not a train track. Yeah, the public street. It only goes about 21 feet though, so go try to take your car on that sometime.